Hello everyone, this is KenBroTech from KenBroTech and welcome back to the channel. So in this video, you are going to build a Django web application, and this is quite different from other videos that I've done. In this application, we are going to look at a sports prediction website. So what this application basically does is it takes an input, which we are going to provide in this form, and based on machine learning algorithm that I've already built and integrated it with the Django application, it is able to make a prediction or the kind of sports a particular student or is likely to play. So let's say we have a user, and this time around, let me say we have Mary, and we are going to specify Mary's age as 14. So over here, we are also going to put out some restrictions to a lot of things over here. And Mary's height is about 3 feet. And obviously Mary is a female. So when I click on make prediction, you can see that Mary is added to our database. I already had John and Kenneth added in here. So now you can see that Mary is 14, the height is 3, and the sex, I changed it over here to some kind of categorical data. So 0 for female and 1 for male. And the predicted sport for Mary is hockey. Now let's come back and make another prediction. And this time around, I'm going to say Francis. So Francis, the age for Francis, I'll say 19, and the height is about 6 foot. Let me do 5, and John is a male. So when I click on make prediction, the predicted sport for Francis is basketball. So over here, we are going to use a machine learning model, and we are going to use this particular environment in building our model. So we are going to take a very deep dive into the basics of machine learning. We are going to do some basic data analysis. We are going to look at how we pre-process our data, build our model, and perhaps do some data analysis. I mean, a very small one for that matter. We are not going to go so much deep into this. And don't worry if you're a complete beginner, I'm going to take time to explain the very fundamentals of everything we are going to do over here. And that's why this video is in 2 parts. Now, if you're a complete beginner with Django or web development, don't worry, I'm going to take you through, but I will highly recommend some of my previous videos I did over here. So over here, I have a Django inventory management application. That's about 22 videos I published a couple of months ago, and it takes you from the very basic, like ground zero, to an intermediate level of web development. Then also the other applications you can look out for, and I think you are going to enjoy this. But certainly I'm going to take you through everything that you need to know. Now, if you're excited as I am, kindly subscribe to this channel, and here we go. So before we proceed into building our own machine learning application, we need to understand or get some theoretical foundation. So basically, machine learning is a study of algorithms and statistical models that enables computers to perform a given task without explicit programming. So explicit programming will lead us to what I will refer to as the traditional approach of programming. Now we are going to look at an example very soon. So let's say we want to use the alarm clock use case, and this alarm clock is probably what we have on our phone, or maybe an alarm clock as you can see me display over here. Now this alarm clock, we are trying to program it such that it is going to wake us up at 5 a.m. Simply put, it's going to trigger an alarm at 5 a.m. And when we are using the traditional programming approach, we use logical statements and some computational calculations in our approach. So for instance, we can set a wake up time to, let's say, 5 a.m. and we are going to put out some logic if you are to use the traditional programming approach. And the logic could be, if the current time, which in this case we are going to pick like the system time over here, is equal to the wake up time, then alarm.sound, and this alarm.sound will be a method we've written ourselves or we are importing from a library. So this is going to be the traditional programming approach. Now this traditional programming approach may have its own merits and demerits. One of the inefficiencies of the traditional programming approach that it may not act in an intelligent manner, in the sense that even if we are awake before 5 a.m., let's say we wake up at 4 a.m., it is still going to sound. If we oversleep, it is still going to sound, and it may not make that intelligent decision. We want to have a situation where the alarm is going to sound exactly when we need to wake up. and that's where the machine learning comes in. So within the machine learning approach, we are going to use algorithms and statistical models. I've made mention of that. So what we have over here is going to be a machine learning model. This is going to be like a black box, and what goes into it is our input data and some desired output we would want from the model. And at the end of the day, we are going to have our program. Now let's dive deep into some of the things I've already mentioned, and first of which is data. So instead of just writing if parent time is equal to wake up time, alarm does sound, we are actually going to provide data to the model to make that intelligent decision for us. So this is a typical example of a data. Let's say this is 1st January 2010, okay, and we are picking this whole data set from 1st January 2020. So we are assuming that we are actually taking 10 years long of data, and over here we have the days listed up over here. So we have Monday, Tuesday, Wednesday, Thursday, Friday, up to, it goes on and on and on. And we have the temperature. Okay, so let's say the temperature for Monday 1st January 2010 was 200 Kelvin, and it goes on over here. And we have the sleep time. So on Monday we slept at 7 p.m. on Tuesday we slept at 4 p.m. and the wake up time, as you can see, is awake time next morning. So on Tuesday morning we woke up at 6 a.m. Wednesday morning we woke up at 5 a.m. and so on and so forth. So now it is this data that we are going to provide the algorithm that we are going to build, and based on some computations that will be done, we need not to worry so much about those computations, but the computation will be done and it is going to make a good prediction for us. So then we are in 2021 now at the time of recording this video, so that we can use, based on this data set, and predict, let's say 2021 Monday, what time will it be best for me to wake up, and the system is going to make that prediction and the alarm is going to sound. So in order to build a machine learning model, we need to have some kind of theoretical understanding of the whole flowchart. So within this flowchart, first of all, we need to import the data. Then we need to do some pre-processing of the data. We need to split the data into a training set, or a training part, and a testing part. Now we are going to use the training part to build our machine learning models. We are going to use the testing part to test the machine learning model. Then finally, we are going to do some analysis of it and make predictions. So what are then these algorithms I kept mentioning? Now, if we want to look at the algorithms, then we first of all need to draw back and look at the machine learning techniques or approach. Now, there are basically two main types, which is the supervised learning and the unsupervised learning. However, if you would want to stretch that conversation, we are going to come into the reinforcement learning. Now, within the supervised learning space, we can have logistic regression, linear regression, decision tree, SVM stands for support vector machines. We have the naive Bayes, we have the KNN, which is the K nearest neighbor, random forest, neural networks, and the list goes on and on and on. We need not to reinvent the wheel. These algorithms are already there. We just have to use them. So what it means is, if we decide to use, for instance, linear regression, we just need to build that model using linear regression and put the data inside of the linear regression for you to make the prediction for us. That's all that we need to do. If we decide to use an unsupervised learning method, then we can fall on the k-means, the hidden Markov models, the Gaussian mixture models, of course the neural networks. And with reinforcement learning, we can have q-learning. So now let's come back to what supervised learning actually is. So now supervised learning is a task-driven approach, in that we have an input data and we have a desired output. So the input data will be mapped to the desired output, and that's what the algorithm, for instance, decision tree, is going to do for us. Now when we come to an unsupervised learning, there is no desired output technically. So what happens is, it is going to look out for intrinsic similarities within the data sets and cluster them or group them, so that we can have those groupings, and any other example that will be introduced will be made to fit in those groupings. Now with reinforcement learning, we are looking at a learning approach where an agent will perceive its environment, and based on how well it is doing in terms of learning, it is being given a reward. And that's basically how human beings learn. Technically, if you know there's an exam tomorrow, if the stakes are high, you will learn. There's some kind of motivation in reinforcement learning. So now, what are the applications of machine learning? What then can we use machine learning for? Machine learning is basically the driving force behind any artificial intelligence system we see around. So for instance, we can look at it from the e-commerce space, and that's where we have the recommender systems. So you go to Amazon, you go to some of these e-commerce websites, and strangely you realize that you are buying something and they are recommending something for you, and what they are actually recommending is something you need. So clearly they pick up data from your previous buys, they pick up data from other people living close to you and what they are buying. Definitely they make that prediction. Now we can also have a disease diagnosis system within the health space, and what this basically does is it can pick up some kind of symptoms, okay, and based on the symptoms predict maybe there's a kind of disease you probably might be suffering from, and maybe the severity of that disease. Within the business space, we can look at it from the stock market predictions. Within the tech space, we can look at it from the self-driving vehicles, and these applications are endless. Day in, day out, people are building marvelous applications using machine learning. So the computer vision systems based on some machine learning model is going to be a subcomponent of the self-driving car. And within the industry, there are industrial robots that are thriving on machine learning models in order to perform a specific task. So then let's summarize everything over here and move on onto building a machine learning model. So the problem you are trying to solve will determine the algorithm to select. So remember, you have the supervised learning, unsupervised learning, and reinforcement learning. So based on the problem you are trying to solve, that will lead you to a particular algorithm. Then also the machine learning approach thrive on data. The more data you have, the better. The larger data sets, the better, because it's almost as if you are learning for an exams. If you learn more, solve more examples, read more, you become more confident and more prepared for the exams, and that's exactly what happens in machine learning. Then we're also going to look at a situation where building a good model is not always a straightforward thing. Okay, we are going to see. Now this could be, or there could be a number of trials with different algorithms, changing parameters within the algorithm, and also using a number of different algorithms. So remember, within the flowchart, I made mention of the fact that in most cases we need to perform a pre-processing of our data. So if there are some missing data, if there are some noise within our data set, we need to pre-process them. And in most cases, we are going to use, let's say, a different machine learning algorithm to do that pre-processing before we move on into building our main algorithm. Alright, so the first thing that we are going to do is to build our model, and we are going to use Google Colab. So Google Colab is some kind of an IDE that we are going to use, and the reason why we are not going to use our VS Code for now is the fact that when you are building machine learning models, you need some kind of an interactive IDE that you can view data, and I'm going to show you as we move along. So I'm just going to do a Google search. So I'm going to do Google Colab. You can do it this way. I'll leave the link in the description below. So this is research.google.com, and we are going to have access to the Google Colab. Alright, so once this is open, first of all, let me just click on cancel and show you. So this is going to be the interface we are going to use, and let's click on file and let's say create new notebook. So we have new notebook over here. Let's click on this. So over here we have this notebook showing up over here. Now we can click on this to expand this so that we see exactly what's happening over here. Now the first thing I would want us to do is to change the name what we are having over here. So I'll just do this and change the name to ml_model. Alright, so we have ml_model.ipynb. So ipynb, this is not a .py extension, this is an ipynb, and the ipynb is simply the extension for the notebook environment. Now if you have Anaconda, that's great. You can use Anaconda and use Jupyter within Anaconda to handle this, and the interface is almost the same. So what we have over here is the cell. Okay, so over here we can write normal Python program. So let's say we can have a name, and name is Kenneth, that's my name, and I can do a print name over here. So when I run this, and in order to run this, I need to click on this button over here. So as you can see, when I hover around it, it says run cell, and I can use Control Enter to run it as well on my PC. So when I run it this way, now you see we have Kenneth printed out over here for us. Now we need to always write our code in cells. Okay, so what we can do is we can actually click on this button. Okay, so it says insert code below, insert code cell below. So when I click on this, you can see that we have a new cell over here. Now let me do another print statement, and let's say I have 2 plus 4. Now instead of running it over here, I'm going to do a shift enter. So shift enter is going to run this, and it is also going to create a new cell for here, a new cell over here for me. Now I made a mistake. I'm supposed to do plus 4. So 2 plus 4. And we are getting 6 over here, and as you can see, the new cell has been created. Now you can click on this cell and actually delete the cell. So when I click on this button, I'm going to delete the cell. When I click on this one too, I've deleted the cell. All right, now within this Colab environment, some Python libraries are already installed for us, so we need not to worry, and that's why I'm using this. If you are to use Jupyter, we need to go through the cycle of installing all the libraries we are going to use. But over here we can do, let's say, a pip list. So I'll do pip list and do a shift enter, and this is going to list all the packages in here for us. So as you can see, there are quite a number of them. I haven't counted, but they seem to be a lot, and everything we are going to use is basically in here, so we need not to worry so much about everything over here. So once again, let me just delete the cell. Now you can see we have a text over here, so you can use this text to put up markup, okay, some kind of descriptive notes around. Okay, this is not necessarily a comment, but then you can just write things over here. So I can say this is a new section. All right, so this is a new section, and when I run this, and I'm also going to do the shift enter. So as you can see, this is a new section over here. I can click on it, double click, and let's say select everything and click on this. Okay, so this is going to toggle the heading, so the heading is going to be bigger. So as you can see, there's a preview over here, and when I click on it again, this has changed. When I click on it again, it is also going to change. So if you have it this way and I do a shift enter, and see that this is a little bit bigger than it used to be. All right, so let me once again delete this as well, and now let's move straight into action. So let me put out a cell over here, or I mean a text, and I'm going to say import libraries. So import libraries is going to be here, and I'm just going to toggle this to make it look a little bit big. Now if I have it this way, and I would want to have it at the very top, as you can see, there's a cell over here. I can just do or use this arrow keys over here to bring it up. Okay, so now this is making it go down. No, I need to select on this particular cell and actually send this up. All right, so I want to import libraries over here, and I'm going to say I want to import pandas as PD. So pandas is a Python library that we are going to use to manipulate our data. All right, so now the question is, where is our data? Because we are going to work with a machine learning model and we need data. So over here, when I click on this, okay, files menu over here, now Google Colab gives us some sample data we can use with our work. So when I open this up, you are going to see we have the California housing data set, we have the MNIST data set, and we can use this. But these data sets, I don't want to use it. Let's use our own data set, and maybe in other examples with other tutorials I can look at that. So I'm going to click on this upload file session, and I have this data set over here. This is what I'm going to use. So it is within my desktop folder. I have a subfolder called data, and I'm going to just click on this and open it up. All right, so I'll do yes. All right, so the first thing, so now we are going to import the data, And once again, let me put out a text over here, and I'm going to say import data. So I'm going to do a Control A, make it a little bit bigger, do Control Enter, and I want to put this up. So I'll select it and put it up over here. So I want to import data, and this is what I'm going to do. So I'm going to call in a variable data, and I'm going to use the pandas I've imported over here. So I'm going to say pd.read_csv. So there are a number of data file extensions, and this is a .csv file. This is a comma separated variable file. So after calling this method, all that I need to do is to pass in the directory or where the file can be located, or the name of the file. So I'll do sports_data.csv. Sorry, CSV. Alright, so when I do a shift enter, and if you don't have any problem over here, you can see that after running, we don't seem to have any problem over here. So the data will be accepted. But then if I am to make a mistake and let's say forget to bring the file extension, and let's say I run it, we are going to have an error. Alright, so as you can see, we have an error over here, and the error says no such file or directory as we specified over here. So it was looking out for the extension, and we can read this comment and make meaning out of it. So I'll just quickly bring the CSV extension over here and run it again. Alright, so we don't seem to have a problem. So now we have the data over here. So let me just bring out text, and let's say I'm going to say data analysis. So I'll say basic data analysis, and I'm going to also make this a little bit bigger. I'll do a shift enter over here, and let me put this up. Alright, so the data analysis, now we have this data imported, the sports data. So now let's have a look or a view of it. So when I just do data and do a shift enter, this is going to print it out for me over here. And these are some of the reasons why we need an ID of this nature, because in VS Code we cannot be seeing data like this. It's going to be in the terminal, and we probably may not feel comfortable working our way around this. So this is the data in its entirety. So now with this data, we can see that we are starting from index 0 and ending at 18. So like we have 17 over here. So we have 18 rows, and within 18 rows we have the age, the height, the sex, and the sports. Okay, so this is going to look a little bit clumsy if, for instance, we have 1,000 data sets. We can't be having everything showed up over here. In fact, the environment is not going to show us everything over here. But in most cases, what we would then need to do is we can do data.head. So when we call the head method over here on data, it's actually going to display the first 5 rows. So as you can see, this is the first 5 rows. So starting from index 0 to index 4, we can actually do or also do data.tail. And if your guess is as good as mine, data.tail is also going to display the last 5 rows of our data set. So as you can see, we start from index 13 and ends at 17. So this is the first thing we are looking at. So sometimes it's good to inspect the data. Now let's look at the shape of the data. So let's do data.shape. When I run this, data.shape is going to show me the dimensionality of our data set. So as you can see, I have 18 rows and 4 columns. Okay, so these are 18 rows I spoke about, and the 4 columns are age, height, sex, and sports. So we have that over here. Now let's do data.describe. So when we call the describe method over here, we want to kind of see some kind of description of our data set, and it's very interesting to note. So within our data sets, okay, we have the age and height, and we are getting some statistical analysis or description of the various data sets over here. So for instance, we have the count. So the count is the number of instances we are having each input in there, and we have 18. For height, we have 18 as well. Now the mean is the average. So the average age is about 15.1 years, and the average height is about 4 foot. And we have the standard deviation showing up over here. The minimum age, as you can see, is 13, and the maximum age, that's the last rule over here, is 19. Same with the maximum height is 6, and the minimum height is also 3 foot over here. Now we have the quartile distribution, the first quartile, second quartile, and third quartile. As you can see over here, these are purely statistics we need not to worry about. All right, and this is not even anything to do with machine learning, but we just have to see some of these things so that this will actually inform us during the pre-processing stage. Now, as you can clearly see, the sex and sports didn't come here because as far as these statistics are concerned, they cannot have some kind of numeric value. That's why they are not showing up over here, but then we are still going to use them one way or the other. So going back to our main machine learning building model approach, where we looked at the flowchart, the first thing we needed to do was to import data, and the second thing was to pre-process data. So let's try and do some kind of pre-processing over here. So I'll bring in this markup over here, and I'll say pre-process data, and let me make this a little bit bigger like this. All right, so within the pre-processing of data, we can look at it from a number of ways. Now this is not actually going to be exactly how we are going to pre-process every data set you are going to use within a machine learning model, but I would want us to change the sex. Okay, for the sex column, I would want us to change it into some categorical data, and this is what I mean. I would want us to have all males being represented as 1 and all females being represented as 0, and that's basically what we are going to use in order to crunch the numbers and make meaning out of it. All right, so what I'm going to do is I'm going to do data. Okay, we have data in here. I'm going to call this bracket over here, and I'll do like I'm selecting sex. Okay, then I'll call the dot replace method on this, and the question is, what then do I need to replace? I want to replace female, and also I want to replace male, and it's actually a capital M. Okay, so I want to replace this with 0 and 1. So the order is very important. Okay, so female is going to be represented with 0 and male is going to be represented with 1, and I'll specify an in place is equal to true over here. All right, so after doing this, when I run this, we don't seem to have any problem over here, so it has been accepted. Now let's look at our data sets. So let's do data once again, or let's do data.head so that it doesn't print out everything over here. So as you can see, the sex for male has changed to 1. Okay, because over here you can see that everything over here was male, 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 and that's exactly what you are seeing over here. Let's do data.tail, and you can see the female has also changed to 0. So that's exactly what you wanted. You wanted to have some kind of categorical data. All right, so now we have this pre-processing done. Okay, so the next thing we are going to do is we are going to import the machine learning libraries. Okay, so I'm also going to put out a markup over here, and I'll say import machine learning libraries. I'm going to select this and use the big markup over here and send this up. All right, so in here, like I said, we need not to reinvent the wheel. These algorithms are there, and we are going to use the decision tree algorithm because this is a supervised learning method that we want to have. And let me show you exactly what we are trying to do. So over here, given the age, the height, and the sex of a student, we would want to predict the kind of sports that student is going to play. based on these data sets. Okay, so as you can see, this is going to be our inputs: age, height, sex, and our predicted value is going to be the sports. So if you are to use, let's say, x and y variables, age, height, and sex is going to be our input, which is going to be our x parameters, and our y parameter is going to be the sports. We are going to come there later on, but in order to use these models, we are going to say from scikit-learn. So this scikit-learn, which we are going to call sklearn over here, is a library that has almost all the machine learning algorithms we would ever need. So we are going to say from scikit-learn.tree, I'm going to import the decision tree classifier. So we are going to have the decision tree classifier over here imported. Then I also need to import something. So I'm going to say from sklearn dot model selection, I want to import train test split. Remember, I made mention of the fact that we need to split our data into a training set and a testing set, and that's why we are importing the train test splits from the model selection within scikit-learn. So I'll run this, and we don't seem to have any problem over here. Now remember, I made mention of the fact that we will have the x inputs, okay, which is going to be age, height, and sex, and the y input is going to be the sports. So let's do that quickly. So our x inputs is going to be equal to data dot drop. And what do we want to drop? We want to drop the sports. Okay, we want to drop the sports. So you're going to specify a column over here, and for the columns we are going to say sports. All right, so now when I do this and run it, and I say call x.head, and it's prudent, whenever you do some of these things, you check it up to see exactly what you've done, and if there's a mistake, you solve it immediately. And that's why the Jupyter Notebook or the Colab within this environment is very helpful. So as you can see, this is the x inputs, as we are calling the x.head over here. We've now dropped the spot because this is going to be our input variables, and we are going to use this to make the prediction. So clearly our y, which we are going to specify as small letter y, is also going to be data.drop. You can use the dot drop over here. And what do we want to drop? We want to drop some columns over here. So the columns that we need to drop are going to be the age. We also want to drop the, let me check it out over here. So we want to drop age, height, and sex. So age, height, and you also want to drop sex. All right, so when I run this, we don't seem to have any problem over here. So when I do y.head and run this, we are also seeing that over here too, we only have the spots showing up. All right, so we are going to feed our model with this x input data sets, and we are expecting a y prediction. Good. Now remember, I also imported the train test splits over here because we want to split our data into a training set and a testing set. So in order to do so, I'll quickly come in here, and we are going to have our x train portion of it, and we're also going to have our x test portion of the data sets. Likewise, we're going to have our y train and our y test, and I'm going to explain exactly what's happening. So we are doing unpacking over here. So I'm going to call the train test split, and over here all that we need to do is to pass in the parameters, okay, or the data set, which is the x and y. So we are passing in the x and we are passing in the y, and we are calling this train test split over here to split this into a training set and a testing set. But within the training set, we are going to have the x training sets, and we are also going to have the y training sets. Now we are not quite done yet, but we can leave it as it is. But then we also need to specify the ratio or the proportion in which we need to, or we want to split it. So we can do a test size. and we are going to do a 0.3. 0.3 basically means that we want the testing parts of the data set to be about 30%, for the training set to be 70%, and this is pretty much the standard. So when I run this, we don't seem to have any problem over here. So this has been done. All right, so now we are going to go on into building our model. All right, so in building our model, once again, let me just put out a text over here. So I'll say build machine learning model, and I'm going to select everything over here and make it bigger like this. So I'll run this, shift enter, and I'll send this up. All right, so building a model is as simple as this. So we are going to call in a variable, and I'm going to call this CLF, which basically is like classifier, and we are going to call decision tree classifier over here, and this is our model. Okay, remember we've imported from sklearn.trees, we've imported the decision tree classifier. We need not to reinvent the wheel. This model is already there. We just have to use it, and we need to understand why we are using it, because we want to build a supervised learning model. All right, so this model has been built. When I do a shift run, so this is part of the building of the model. Okay, so what we've done over here is like to instantiate the model. Now we need to complete the building of it. So we can do the CLF, which is the model, okay, which is the model dot, and we are going to say dot fit, and this is where we are going to fit in the X train or the X data sets, the X train and the Y train. So remember, I made mention of the fact that we are going to use the training part of the data set to build a model, and that's exactly what we are doing over here. So we are fitting this. I'll do a shift enter, and we seem to have a problem over here. All right, so our problem is actually coming from, so it says the number of labels 6 does not match number of samples 12, and checking up over here, we made a mistake over here, or I made a mistake. Okay, so as you can see, we have the X train, we have the X test, we have the Y train, and we are supposed to have a Y test over here. So I made a mistake. All right, so let's start running it over here. So I'll run this once again. All right, so this is not having a problem, and let's instantiate our model over here, and now let's build the model. All right, so this is what we are going to see. If it is a very small data set, it's going to quickly pick it up and build it. So it says the decision tree classifier, and it gives us these parameters. Now remember, I made mention of the fact that we have some parameters we can change, and these are the parameters. So depending on what you are building and how good the model is, you can change these parameters over here, and we are going to see a number of examples very soon. All right, so now that we are done with building our model, now we need to test our model. And remember, within our flowchart, we are going to use the test side of, or the test part of the data set to test our model. So over here, let me put out a markup over here, and I'm going to say test ML model. So in testing our ML model, let me also do this. Let me take this up a little. All right, so in testing our machine learning model, all that we need to do is we can call in the classifier, which we specified as CLF. Okay, so we can do CLF dots, and we have a method over here dot predict, and we can actually pass in the X test over here like this. Good, and let's put out a variable over here, and let's call this test. All right, so test is equal to the CLF, which is the model we built over here, dot predict, and we are passing in the testing part of the data set over here. So when I run this, well, and if I'm to do or print out text, it is actually going to put out the model, or it's going to put out the testing for us. Now we can do a direct comparison with this, and in order to do so, let's do the Y test. Okay, because We want to test and see if what was predicted is actually equal to the test or the y test. So within y test, as you can see, we have soccer, basketball, hockey, soccer, and we have hockey, soccer, basketball. There's some kind of issues over here, but clearly if you have to look at it from the very bottom, you can have soccer, you have soccer over here, then you have hockey, you have hockey over here, then you have basketball, we have basketball, we are supposed to have basketball over here, and now we have soccer, hockey. So some predictions were made right and others were made wrong. Now in order to see exactly which prediction was right or the level of accuracy, we need to check for the accuracy, and that's why some of these things are very important. So now let's put a marker over here and say check for efficacy. We want to check for the efficacy of the model and change some parameters if they need be. So let's put this one up over here. So in checking for the efficacy, we need to run an import over here, and I'm going to say from sklearn or from scikit-learn dot metrics, we want to import, and we are going to import a number of them and use them as we move along. So we are going to say we want to import the accuracy score. We also want to import the confusion matrix. We want to import the classification report. So we are going to use the rest later. Now we are going to only concentrate on the accuracy score. So let me just run this. I'll do a shift enter. All right, we don't seem to have any problem over here. So let's check out for the accuracy of our model, how good our model is able to make a prediction. And let's call in a variable. Let's call this accuracy. And accuracy, we are setting it out to be the accuracy score. We are calling this accuracy score over here, and we need to pass in some parameters. So there's a lookup over here. See that we need to pass in the y true, the y predict. Okay, so that's basically, in our context, is going to be the y test and the prediction. And in this case, let me check. So we use test over here. Okay, so let's use tests over here as well. So let's use test over here as well. All right, so when I run this, now let's print out the accuracy over here. So when I print this out, we are getting about 66%. Okay, and this may not be good enough, because we want, if we can do better, then we definitely have to go in for that. So one way to actually do better is to come in here and change some of the parameters over here like I specified. Then also we can also change what we have over here for the test size. Let's say, let's do a test size of about 35%. This is drastically going to change a lot of things over here. Now let me show you this. Now over here we can click on runtime, and when I click on run all, it is actually going to run all the cells I have over here. So when I click on this, and let me count down here because it is the accuracy I'm looking for. So as you can see, the accuracy has dropped to 57%. Let's run this once again. It is still dropping. Okay, so clearly increasing our test size is not going to solve the problem. Let's maintain to 30% over here, and let me run all once again. Now we are back to 66%. Let me run it once again, and drastically we've gone down to about 16%, or approximately 17%. So what's happening over here? Now anytime the program runs and comes to this part of the program, okay, that's the train test splits, it randomly splits the data sets. So depending on how random that operation is, it is actually going to affect our accuracy over here. So let's run this once again. and now you have 33%. Let's do it once again. In fact, let's do it till we get above 80%. All right, so over here, after running this for a number of times, I have 83%. So let's say this is what we want. We are satisfied with the accuracy. You want to go with 83%. We can do better, and we are fortunate we are using a very small data set. That's why we are able to run it very quickly. But then if the data set is huge, it is going to take some number of minutes or even hours, depending on how large and how complex the data set is. Then also, if the data set is big, because machine learning thrive on big data or large data sets, we're also going to improve on the accuracy. Okay, so there's a trade-off. The bigger data set is going to take a longer time to run, but then we are going to get the accuracy. So perhaps maybe you need to run it maybe a maximum of 5 times, but we are definitely going to have a very good accuracy, maybe in the region of 90% plus. But at least 80% or 83% is good for what we are trying to do, taking into consideration how small the data set is. So let's call a variable over here, which I'm going to call new students. So new students is going to be the clf.predict. We've seen this before, and we are going to pass in our parameter over here. So we have 15 for 1. So the age is 15, the height is 4 foot, and the sex is 1 for male. So when I run this, we seem to have a problem over here. So the error value reads expected a 2D array, got 1D array. So basically what that simply means is we just need to pass in or make this a 2-dimensional array. So we need to bring another square bracket over here like this. So I'll run this once again, and now we don't seem to have any problem over here. So now let's go to new students, or let's print out the predicted value for new students over here. So when I run this, we are getting hockey over here. So now that we have this on our way, we want to save our model, and this is very important because remember, running this over and over and over again can be computationally expensive. It can take a lot of time. So if we get a very good model with a very high accuracy, we would want to save it. So now let's put out this over here, and I'm going to say save model, and I'll do shift enter and send this up over here. So in order to save our model, we are going to also use scikit-learn. So I'm going to say from sklearn.externals, I want to import, and we are going to use joblib. So joblib is a package within scikit-learn.external that's going to help us to save our model, and we can use the model anytime that we want. So having imported joblib, we can now call on joblib to save our model, and we can simply do joblib dump. We need to pass in some parameters over here, and the first parameter we need to pass in is the name of the model, which is CLF. Okay, as you can see, the name of the model and the name of the file that we want to save it to. So this is going to be a strange value, and I'm going to say ml_spot_model dot, and there's a file extension over here. So the file extension is joblib. All right, so when I run this and save, we have this saved over here. Now it's supposed to save over here, but then we are not seeing that quite yet. All that we need to do is to come in here, click on file, and we need to save this. So we can actually do control save over here, and once it is done saving, as you can see, saved successfully. We can now come here and come and refresh, and let me open this up, and when we refresh, now we have ml_spot_model.joblib. all right, so now we have our model saved, and we can use this model anywhere and anytime that we want, we can actually download this model, okay, and use it in our future application without having going to go through the process of building, training, and testing the model like we have over here. So all that I need to do is I just need to click on this button over here, and as you can see, there's a download option over here. So I'll click on download, and this will be downloaded and sent to my download folder. So that's what I have over here, the ml underscore model job lib. Okay, all right, so that's what we have over there. Now let's try and, like, let's say open a new notebook. So this is a new notebook I have over here, and let me open things up over here. As you can see, we don't have the data over here, so I can do file, and no, let me try and import some kind of a file over here. So let me click on upload file, and instead of coming into my download for me to grab the data and work with it, I can simply go into my downloads over here and grab this model that I worked with and bring it here. Now I have this model over here. Let me try and rename this to this. And in order to use this, all that I need to do is, first of all, I need to just run the imports. So I'm going to do from scikit-learn.trees. I want to import the decision tree classifier. Then I'm also going to do from scikit-learn externals. I want to import job lib. Alright, so when I run this, I don't seem to have a problem over here. Now I can do job lib .load, and I'm simply going to load this model that I have over here. So that's going to be the ml underscore port underscore model dot joblib. So when I run this, alright, so I think the problem had to do with when I renamed it. So let me click on this and come back to the renaming. And I think there was a space over here, so let me get rid of that space. And alright, so this should be it. So let me do a shift enter to run this, and as you can see, the model has been built. We didn't have to put out a lot of things over there. Alright, so we could have also, and let me actually do that. So let me call in a variable model, and model is now equal to this. Alright, so let me load this once again. Now we don't seem to have any problem over here. So now we can do model dot fit. Alright, and we need to pass in the parameter. Remember when we were doing it over here, we did model dot fit over here. Let me see. Okay, so this was like the classifier dot predict. Okay, now we've changed that to model. So I mean, it can be any name. So let's do a predict over here. So let's do 1541 and see if we actually get the same hotkey as it was previously predicting. So let's say new student 2 is equal to, let's do model dot predict instead. So model dot predict, and let's pass in I think 1541, and let's run this and see. So we don't seem to have any problem over here. So let's do new student, or let's try and print it out. So new student, and see we have hotkey over here just as we had over here. So our model has been saved. We can do our prediction and we don't have any problem with it. So as you can see, since we have the model saved over here, we need not to build it again. We just have to use this in our program and we are good to go. All right, so before we continue with that, I would want us to do some kind of data analysis and visualize things over here, because that's also important in understanding the accuracy and how things are happening over here. So remember, I made mention of the fact that beyond accuracy, we have confusion metrics and we have the classification reports. Let me also import one last one. So I'm going to say from sklearn.metrics, I want to import, and I'm going to say plot confusion metrics. All right, so let's have this done the way. Now what's the confusion metrics? And we are going to see the confusion metrics very soon. So for the confusion metrics, I'm going to say or I'm going to call a variable, and I'm going to call this C metrics, and C metric for confusion metric is going to be equal to the confusion metrics I imported over here. Okay, I'm going to call this, and I'm going to pass in some parameters over here. And the first parameter I need to pass in is a y test, and the test as well. Okay, so the test is actually like the prediction. Let me show you. Yeah, the test over here was the prediction. So let me also pass in the test over here, and let me print out the confusion metric. So I'll do C underscore metrics as I've specified over here. So let me change this to matrix. All right, so this is a confusion matrix that I'm referring to, and this is what we have. I'm later going to explain exactly what's happening over here, but then let's take it like this, and let's come back here and also do an import over here. So I'm going to say from matplotlib. Okay, I want to import pyplot as plt, and this is actually going to help us with plotting graphs and trying to visualize data. Okay, so there's a package in here called matplotlib, and we are importing pyplot within it as plt, and when we have it this way, all right, we are good to go. Now remember, I imported plot confusion metrics over here, and we want to plot this confusion metrics we have over here into a more graphical image so that we can see exactly what's happening. So in order to do so, all I'm going to do is I'm going to call the plot confusion metrics method over here, and the first thing I need to pass in is the model, which is the CLF or the classifier, as we specified over here. Yeah, when we are building the model, you see we have been using this all along. Okay, so the CLF, so that's the first parameter we pass in side of our confusion matrix plots. Then the next one is going to be the X test, and finally we are going to put out the Y test. All right, so if I'm to run this, shift enter, we are going to have a graphical illustration of a confusion matrix. So now, as you can see with the array we have over here, you can see that we have 101, and that's exactly what's showing over here, 101, and we also have 030, 030, and you have 001. We also have 001 over here. Good. So what is actually happening over here? On this side, we have the true labels. So we have basketball, hockey, and then we have soccer. And on the predicted labels, we have basketball, hockey, and soccer. So this is what is happening. If we have the true, okay, the true label as basketball and the predicted label also as basketball, then clearly the prediction was right. But with this particular one, we can see that on the true label it was basketball, but on the predicted, it was predicted as hockey. So this is what we call a false negative. We can look at this, and that's going to lead us into data analysis, and that's beyond the scope of this work, but then we are looking at some few things over here. Now let's look at hockey over here. So hockey over here, this is the true label, and all three was predicted as hockey. Okay, and the predicted was actually hockey, so we didn't have any problem over here. And when we came to soccer, we only had one label for soccer, and it was actually true. So it was with the basketball that we had some of its predictions being taken in as soccer. Now let me actually print white test over here for you to see exactly what's happening over here. So within white test, you can see that, you see, the white test is what is being used to juxtapose everything happening over here. And as you can see, we have the model. As far as the plot confusion matrix is concerned, we have the model, we have the X test, and we have the Y test. So we are comparing what we built with our model, put out the Y test and compare it to the X test. X test and compare it to the Y test. And as you can see over here, this is our Y test. We had 3 samples of hockey. So we had 1, 2, 3 for hockey. Okay, and that's why we're having 3 over here. And with this confusion matrix, what's happening is all the labels that were hockey were actually predicted hockey. So as you can see, when we draw a match, we can see that the predicted hockey, the number is the same as the true label hockey. So hockey didn't have any problem. Now we had 2 basketballs samples over here. And for the 2 basketballs, one was predicted correctly. So we had a true label for basketball and a predicted label for basketball as one. The other label for basketball was wrongly predicted as soccer. And that's exactly why our accuracy is not yielding us 100%, because clearly there's some disparity in there. And some of these things are going to make you understand or appreciate exactly what's happening. Now we had the actual soccer over here, which appeared 1. And it was actually also predicted true as soccer. So we don't seem to have any problem with soccer, but it is only with basketball that we had that kind of a shift. Now this is so because, you see, when we have a data set, the bigger the data set, the better it is. Now this data set was very small, and we have 3 classes over here. We are predicting to either, or we are making a prediction to either fall within the class of a basketball, a hockey, or a soccer class. So there are 3. But as you can see, there's some kind of imbalance over here. When we randomly splitted our data set into a training and testing parts, hockey alone had 3 samples, basketball had 2, and soccer had 1. So clearly there's some kind of imbalance going over here, and this is because it was done randomly. Now in real life machine learning problems, we need to actually save our testing data sets and our training data set, and that's exactly what we have over here. So remember, I showed you this earlier on with a sample data. When I open this up, you can see that for this particular data set, the California housing data set, we have the test part which has been saved separately from the train part, so that there's some level of consistency. But because we didn't do that, we randomly had to split things up. That's why some of these things are happening, but it is quite expected. You need to know what you are doing and what is expected, so that if there are things you can change around it, you do same. Now let's look at the classification reports. Remember, we've looked at the accuracy. As you can see over here, we've looked at the confusion matrix, and now we have the classification report. So like I said, this metrics we have over here, this is a graphical representation of it. So now let's look at the classification report, and we can call the classification reports method over here, and in here we pass in the Y test and the prediction, which is actually the test. Okay, the prediction, which is actually the test. So now when I run this, we are going to have this report showing up over here. It doesn't look pretty, but then let me just copy this, okay, and paste this over here. So I'll do a Control V, and this is essentially what we have. We could have actually put this in a print statement. So let's do a print method over here, and if I should run this, it looks pretty like we have over here. So now what then do we have? We have a precision, recall, F1 score, and support. This is very important in data analysis. So as you can see, as far as the precision goes, so basically the precision is how accurate you were, and the recall is more or less the opposite of precision. Remember, I made mention of true positives and true negatives, false positives and false negatives, and I was trying to use this classification reports or the confusion matrix to actually explain that. Now that plays a lot of role in this report that we have over here. So for precision, we didn't have any problem with basketball. We had 1 over here, but the recall was like half of it, or 50%. Okay, so the precision is how accurate we're able to predict, and the recall is the opposite, how inaccurate we could sometimes be. And that's exactly showing up over here. So we're able to predict correctly, but at the same time we are making some wrong predictions over here, and that's what we see in this particular report. In the case of hockey, we didn't have any problem with hockey. We had almost 100% over here. So clearly we have our precision 100%, our recall 100%, and our F1 score 100%. Let me touch on F1 score. F1 score is actually the harmonic mean between precision and recall. And let me use a common use case to explain this. So I am an Arsenal fan. Okay, I love soccer a lot. I support Arsenal. And Aubameyang is our striker. So now let's say you don't watch the match and you are given the score line. Let's say, oh, Arsenal scored 3 and Aubameyang had all 3 goals. You'll be very happy. That's more or less like part of the story. So that's almost going to be like the precision. Okay, how accurate you were. But now, if you are told that Aubameyang actually had 10 penalties but was able to score only 3 out of the 10, it gives you a different dimension of what Aubameyang actually did on the day. And that's what the recall comes in. So the recall is actually going to measure how wasteful you were. So within our model, you can see that when we came to basketball, yes, just as Aubameyang, you scored 3, you scored 100% over here. But for how wasteful you were also wasteful half of how resourceful you were. And that's exactly what we are having over here. Now the F1 score will kind of put this all the 2 into perspective. Okay, so how wasteful you were plus how resourceful you were, all divided by 2. So trying to find the mean, the average, and that's what you have over here. So in most data analysis work, you rather want to go with the F1 score because it is kind of trying to draw a balance between precision and recall. But as you can see, we don't have any problem with hockey because hockey is actually giving us very good results over here. And for soccer, our precision wasn't that good, our recall was okay, and our F1 score is also giving us the mean or the average. And as you can see, we have the accuracy over here, which is showing us as 83%. So as you can see, we plotted the accuracy, and within the classification report, we are also having the accuracy over here. So this is very good for data analysis and how best we can analyze this data. Now in other videos, I'm actually going to zoom in more into data analysis and pick up very good use cases of examples where we can actually build very complex applications using machine learning. So now this is going to be the end of this video. This is a part 1 of this video. In the next video, remember we have this saved model somewhere, okay, and we are actually going to use this model into building that particular machine learning application you saw me demonstrate at the beginning of this video. Now if you find this content very useful, there are a couple of ways you can help me grow my channel. Kindly subscribe to KenBroTech and don't forget to hit on the notification button so that anytime I release a video, you'll be duly notified. Also share this video with friends and family who find this content very useful. At KenBroTech, we say learn program, you can do it. Then again, don't forget to pass in any comment or ask any question that you seek clarification to. Thank you very much and bye bye.